We're going to start by looking at some information about significant digits. If we are looking at a degree measure, if we're talking 62 or 36 degrees, then we can answer to 2 significant digits. If we have a measure that's to the nearest 10 minutes or nearest tenth of a degree, then we can go 3 significant digits. If we have down to the minute, so like 48 minutes, or the hundredth of a degree, we can go 4 significant digits. And if we're talking 10 seconds or the nearest thousandth of a degree, then we can go 5 significant digits. So it's a little different there than normal significant digit stuff. Other than that, we'll also be looking at solving some right triangles and looking at solving some applied problems that use angle of elevation or angle of depression. When you talk about solving a right triangle, that really means to find the measures of all the angles and sides of the triangle. If we have figure 19 here, there's 3 angles, 3 sides, so being able to figure out all of those. And again, just a note here, if we have angle A here, then the side opposite that is A. Angle B here, the side opposite that is B. Angle C, again, has to be the 90-degree angle, and side C has to be the hypotenuse. And again, we generally use capital letters for angles, lowercase letters for sides. So here's a problem that we have. We're going to solve for triangle ABC. They give us angle A is 34 degrees and 30 minutes. They give us the hypotenuse, C is 12.7 inches, and they want us to solve that triangle. So again, they tell us it's a right triangle, so we know that angle is 90 degrees. In order to be as accurate as possible, we do want to use given information as much as possible and avoid rounding off in the in-between steps. So use the given information as much as possible, and again, avoid rounding. Alright, so let's see what I can do here. Since I have my angle A, I can use that as the basis for my trig functions. And say, for example, I want to find the length of side A. Well, side A is opposite angle A, and I have the hypotenuse, so I can do a sine of angle A. I actually have that measurement. So I can do the sine of 34 degrees, 30 minutes, and that will equal A over 12.7. So in order to find the length of A, I just multiply sine of 34 degrees, 30 minutes by 12.7, and that will give me the value for A. And that leaves me with an A value of about 7.2 inches. 7.2 inches for the length of side A. Now that is an approximation, so I don't want to use that to find my side B. I could do a very similar process for finding side B. All I would have to do really is, instead of the sine of 34/30, I do the cosine of 34 degrees 30 minutes, and then that equals B over the hypotenuse 12.7. And multiply the cosine of 34 degrees 30 minutes by 12.7. And that gives me about 10.5 inches. And then all I have to do to find angle B is I know that angle A plus angle B would equal 90 degrees. So really B equals 90 minus the 34 degrees and 30 minutes. So angle B ends up equaling 55 degrees and 30 minutes. And so there we go, that we've solved that triangle. We have all 3 angles. And they gave us angle A, we found angle B, and they told us it was a right triangle, so C was 90. They gave us side C was 12.7 inches, and we found A was 7.2 and B was 10.5. In this example, we're given 2 sides. And again, oftentimes in these questions, you're only going to be given this information. It's up to you to make the sketch. So I would highly recommend sketching that out so you can see how things are all related. Looking at those 2 sides, and I don't have either angle A or B. I could find the third side using the Pythagorean theorem. So the of course, a squared plus b squared equals c squared. And we know a and c, so 29.43 squared plus b squared equals 53.58 squared. And so we would square those and then find b squared. And of course we'll subtract the 29.43 squared from the 53.58 squared. So we get b squared equals 2004.6915. Square root that. B is approximately 44.77 centimeters. Again, that's an approximation, so I don't want to use that necessarily in my other processes for finding the other two angles. First thing, to find one of the angles, I need to use an inverse trig function. And I want to use side A and side C. So I could either do the cosine of angle B or the sine of angle A. I think I'm going to choose just to do the sine of angle A would equal the opposite, so 29.43 over the hypotenuse 53.58. So what I need to do is do the inverse sine of the 29.43 over 53.58, and that will give me the angle A. So sine inverse of 29.43 over 53.58. And again, I'm not even figuring that out at this point, what that decimal is. I'll just use the 29.43 over the 53.58 because I don't want to have to round that at all. And so angle A is approximately 33.32 degrees. And I could do the same sort of thing for angle B. And again, I do want to avoid using that angle A to find angle B, although it should give me the same thing. But I can set up an inverse cosine. So the cosine of angle B would equal the 29.43 over 53.58. So again, I do the inverse cosine of that fraction. And I find that angle B is about 56.68. And again, you can see that the two there add up to 90. And so that makes sense because A and B have to be complementary. When solving applied problems involving angle of elevation or angle of depression, we are pretty good with angle of elevation. That seems fairly normal for us. It's that angle there. We do struggle a little bit with angle of depression. So that angle of depression is, if you look straight out, how far do you have to angle down? Some people get confused. They want to think it's from straight down. You know, they want that angle to be coming up. But it's, again, angle of depression is how far are you looking down from horizontal. So be careful with that. Here's a little process for that. We do want to draw a sketch and label it with the information. Use the sketch to write an equation, and then solve the equation. In this case, we have Shelley knows that when she stands 123 feet from the base of a flagpole, that the angle of elevation to the top of the flagpole is 26 degrees 40 minutes, which is pretty accurate measuring. If her eyes are 5.30 feet above the ground, find the height of the flagpole. So again, you can see the sketch, and typically it's going to be up to you to draw that. And so I have the 123 feet. Well, compared to the angle that we know, that's adjacent. And I want to find side A, which again, compared to the angle that we know, is opposite. So the trig function that uses adjacent and opposite is the tangent. So tangent of that 26 degrees 40 minutes is going to equal the opposite side A over the adjacent side 123. And so that's our equation. We solve that equation by multiplying by 123. And we end up with 61.77 feet for the value of A. Now we would add to that the 5.30 feet, and we get 67.07 for the actual height of the flagpole. So again, a little difference there, that A isn't the answer, but we use A to add to the 5.3 feet in order to find the answer. Let's see, so for this one, Length of a shadow of a building is 34.09 meters. The length of the shadow of a building, 34.09 meters tall, is 37.62 meters. Find the angle of elevation to the sun. So we're trying to find this angle B. Again, notice the distance, the length of the shadow is adjacent to angle B, and the height of the building is opposite of angle B. So we're using a tangent again. So the tangent of that angle B would equal the 34.09, the adjacent, opposite side over the adjacent side, 37.62. So in this case, we do the inverse tangent of that fraction. And again, don't round that at all, just type that in as it is, and that will give us the value of angle B. And when we do that, we find that angle B is about 42.18 degrees. Thanks for watching, and hopefully that helped.